Hello, everyone. Welcome to the Oracle Database World session about accelerating cloud deployment with Database Cloud Service. My name is Vineet Kakani, and I'm a product management lead for Database Cloud Services here at Oracle. In this session, we will introduce Database Cloud Service, talk about some of the high-level benefits, and then take a deeper look at automation for various lifecycle operations that enable developers and architects to easily deploy and manage database for their application needs. We will also see that the entire service is powered by the Oracle Converged Database and the benefits of a Converged Database. Oracle Database is architected as Converged Database. This architecture enables multiple different data types to be hosted in a single database. The easy integration of these diverse data types, whether it is RDBMS, blockchain, graph, NoSQL, or JSON, and so on and so forth, reduces the need to move large amounts of data for analytics. A 100% compatible converged database ensures application development can be accelerated, thereby maximizing business values. No longer are the days where for each different data type and different application need, users need to deploy a different kind of database. That is all provided by Oracle Converged Database. Oracle Converged Database powers the Oracle Database Cloud Service as well. With Oracle's Database Cloud Service, or DBCS, known in short, a unified data platform can be achieved that supports multiple versions of the Oracle Converged Database offered with always-on encryption on a security-first infrastructure. New and innovative applications can be developed using standardized APIs and Oracle Application Express, also known as Apex. Together with Oracle Database Cloud Service, application developers and businesses can maintain a competitive edge while maintaining the long-term value of data. Database Cloud Service supports multiple Oracle database versions and 4 tiers of license included or bring your own license options, providing the ultimate flexibility based on your needs. DBCS is offered with virtual machine shapes that scale up to 24 row CPUs. Each VM shape is configured with the optimized memory and network bandwidth to take the guesswork out of the users. A VMDB can support up to 40 terabytes of storage. It is also offered in a 2-node real application cluster known as rack configuration, leading to a max of 48 OCPUs. DBCS provides full automation for provisioning, patching, data protection, disaster recovery, and performance troubleshooting. And just like the Oracle Converged Database, various kinds of workloads can be deployed on a single DBCS, whether it's JSON, whether it's RDBMS, or whether it's time series databases. In the rest of this session, we will take a deeper look at these lifecycle management areas. Before we start to look at the automation for LCM operations, it's important to understand the wide range of management interfaces available for DBCS. Oracle Cloud Infrastructure APIs are the key foundation for all automation and management. Users have an option to use Oracle Cloud Web-based UI or console, which provides browser access via HTTPS. Various software development kits are available for developers to build and deploy apps. Popular ones supported are Java, Python, Ruby, and Go software development kits. DBCS also supports a command line interface for automation and scripting. Finally, Terraform and Ansible support is available for automation and managing infrastructure as code and have become very popular among the cloud users. So in short, the key takeaway from this slide is that no matter what your automation platform or needs are, There are APIs, software development kits, and command line interfaces available for you to program your applications for using DBCS. Now let's take a look at the various lifecycle operations that we talked about earlier. We will focus on automation around provisioning, patching, data protection, disaster recovery, and performance analysis. Let's start with provisioning first. Provisioning or deployment refers to creation of a new database. Now, this can be done in multiple ways with DBCS, satisfying various use cases. A new database can be created either with an Oracle published image or with a custom database software image. A custom database software image is useful for use cases such as build once and deploy many times. So users can specify a template, a list of patches, and create a custom database software image. Once that image is created, it's available for use across environments for users to deploy. Next, a new database can be created from backup of any database. Another popular way to create a database is to clone an existing database. And this is very helpful for dev test use cases. Moreover, in all of these use cases, after creating a database, multiple pluggable databases can be created corresponding to separate application needs. Here, we are showing an OCI console view of an existing database and how with a few clicks, a clone of this database can be created. Now, among the various action available, users, if they want to clone this database, they click on the clone button. And they are presented with a few input parameters to customize so that the new database can be cloned. Users need to provide any host name, IP address, database administration password, etc., whichever variables they want to customize. And once they click on clone DB system, a clone is created within minutes. The clone database is an exact copy of the source database as well as the source operating system and environment. They are copied as well for convenience. At any time, users can find out the details of the source database from the clone database as well. Pluggable databases or PDBs are very common for use for the use cases where users want to have a pluggable database each for an application or department or tenant. Here we show how simple it is to create a pluggable database for app dev needs. Various PDB lifecycle operations such as creation, deletion, and cloning of an existing PDB are also available via APIs and UI. Users can anytime see a list of their pluggable databases along with the attributes such as open mode, closed mode, etc. Let's talk about updating or patching a database and its grid infrastructure. As you know, Oracle releases new release updates every quarter, and we recommend customers to be on the latest release updates per their application needs and certifications. It is very simple to apply a patch for database or GI. There's a pre-check option also available, which informs the users about any conflict or issues that might happen without actually applying the patch. This capability gives users a chance to address any issues in their environment before they go ahead and actually apply the patch in their planned maintenance. Just like provisioning, users can use Oracle published images or the custom database software images they might have created to patch a database. There is an option to upgrade older database versions of a database to Oracle Database 19c as well in here. And lastly, for a 2-node rack VM database, updates are done in a rolling manner, so application availability is not impacted. This graphic shows the various quarterly updates available for a particular database and the various actions available with respect to patching. Users can pick the desired update and proceed to either pre-check or apply. From updates, we move on to the built-in data protection mechanisms for backup and recovery of databases. If users enable automatic backups for their databases, incremental backups are performed once every day, and full backups are performed once every weekend. All the backup configuration options are managed by the service, and users don't need to worry about any configuration parameters or changes. Users see a list of backups available to them should a situation arise for them to restore from those backups. For automatic backups, users can customize the retention period and backup scheduling policies per their organization needs. The second type of backup option is an on-demand backup option available to users, which users can use anytime to trigger a full backup. These full backups are retained until the users explicitly delete them. So these are also termed as long-term backups. Typically, the application's users take weekly, daily backups and then retain the long-term backups on a monthly basis or even an yearly basis. The restore operations provided to restore a database are fairly comprehensive. For in-place restore of a database, users have the option to restore up to a particular SCN, restore to a particular timestamp, or restore from the latest backup. As we discussed earlier, there is also an option to create a new database from the backup, also known as out-of-place restore, where the source database remains intact, but a new database is created from the specified backup. So all in all, very powerful data protection capabilities for the application needs. Let's move on to disaster recovery. Disaster recovery via DataGuard ensures high availability data protection and disaster recovery capabilities built in the service. DataGuard maintains the standby database by transmitting and applying redo data from the primary database. Cloud automation makes setting up of DataGuard stress-free. Users can set up DataGuard across OCI availability domains or ADs, or even across OCI regions, depending on their organization DR policies. Choice of 2 protection modes, maximum performance or maximum availability, are provided while setting up the DataGuard. And these can be changed at any point during the lifecycle of DataGuard as well. DataGuard switchover, failover, and reinstate operations are available to either recover from disaster or for disaster recovery testing. Next, we talk about performance analysis. Native performance monitoring and analysis is built into DBCS. Database metrics, a screenshot of which you see here, help users monitor useful quantitative data such as CPU and storage utilization, the number of successful and failed database logons and connection attempts, database operations, SQL queries, transactions, etc. Users can use metrics data to diagnose and troubleshoot problems with their databases. Performance Hub provides in-depth diagnostics capability for doing Oracle database performance analysis and tuning. With this capability, users can have a consolidated view of real-time and historical performance data and quickly figure out at which point in time the database might have been overloaded or the wait times were higher, leading to application performance issues. Thus, the built-in capabilities enable the application performance and database performance troubleshooting a breeze. In summary, there are three key points to remember. First, Oracle Converged Database supports multiple data types in a single database and removes the need for silos as well as data movements between applications. Second, Database Cloud Service enabled by Oracle Converged Database accelerates journey to the cloud for all application needs. The unmatched high availability, data protection, security, disaster recovery capabilities clubbed with cloud automation for lifecycle operations add tremendous value to developers and businesses. Last but not the least, for additional resources, please take a look at our technical documentation and blogs for the database cloud service with the links provided here. Thank you for listening.